Here we are on the air. So let me do this. I did this very smart this time. How about that? So that's the agenda for today. Do present to everyone. So here's the stuff that people said they want to discuss. We got one from Louis. I think we should start with this one. We got one from Chris. And we got one from me and one follow-up from...
I didn't write the sentence for mine, by the way, just for the record.
Okay, so there is something not right in it. Okay, so I guess...
It's fine. It'll be clear when we get to that section.
Yeah, I didn't know it. Next time you send an email properly instead of like calling me a secretary and hoping that I maintain the agenda for you.
Maybe I should do a pull request against the wiki.
Actually, you can't do pull requests against the wiki, but what you can do is fork the wiki and just go wild.
You can't create pull request. Why not? It's just another Git repo.
Yeah. Okay. So you'll send a bug report or feature request with GitHub. All right. So that's what we want to discuss. So point number one. Take it away, Louis.
So point number one, what's the issue? The issue is that the current setup we have is actually, it works when you build it using Gradle and stuff, but it's not really reflecting what we want. It's kind of a lie, if you want. It's a lie in the sense that the SPI tester should be a dependency in the core module only of the SPI test source set. And that's the only way it should be used as a dependency. Then when you depend on SPI test in implementation, you should pull the SPI tester dependency transitively. And we can fix the Gradle setup so that it works just fine that way, because that's the flexibility Gradle offers. The problem when doing that is integration in the IDE is broken. It doesn't work in Eclipse, it doesn't work in IntelliJ. So that's why there was a change made. And actually the current status is that it seems to work in Eclipse, according to our Eclipse users, because I've not tested it, but it doesn't work in IntelliJ either. You still need to add a dependency manually.
No, you just need to. What I do is I change the scope of a dep. And that works fine.
Yeah, yes, that's true. Yeah.
Hang on. So the original Gradle correct way of doing it doesn't work in IntelliJ or Eclipse.
No, and the original.
The way that we've fixed it now works in Eclipse, but still doesn't work in IntelliJ. But Alex knows how to tweak it further to make it work in both.
You can't tweak it automatically. No. Each time you re-import the project in IntelliJ.
Oh, you have to, okay, so what he's tweaking is an IntelliJ setting, not a setting Gradle about that.
I've tried doing it the IDEA plugin integration way, and I failed. So I don't know how I'm supposed to add a module dependency, etc. I'm not a Gradle guru enough to have figured it out. But even though, that's one problem. Then the second problem is I had a look at the POM files we generate, and especially at the POM file for the implementation module, which should declare a dependency on core, but for the qualifier on core basic, and that it does, and it's normal with the scope, the default compiled scope of Maven. But then it should have a dependency on the core with qualifier SPI test in the test scope, and that should either transitively pull the dependency to SPI tester, which I don't believe is something we can express in Maven. So since we can't express that in Maven, we would need to also add a direct dependency from core to SPI tester. To have
why are we talking about Maven?
Why do we care about that? We don't care about Maven except for published artifacts, right?
No, and we probably don't care about that. So, but what we have for the moment is a weird-looking POM that has a dependency declared once as a compile and once as a test scope, which doesn't make any sense. Because as soon as you have it compiled, the test one is not needed.
Weird looking palm, I mean, sounds exactly like us. In the end of the sun.
Well, you know, there's a simple solution to all of these problems.
So yeah, ends the discussion. The simple solution is just to pull everything that's SPI test.
No.
Into its
simple
own
solution
module.
is everyone switches to NetBeans.
Okay, can we put this guy? Wait, how can I do this here? Mute. There you go. I can't unmute him though.
So seriously, the question I'm asking, because yeah, and I know I'm not the only one, so I'm gonna say it. I'm a pedant for that kind of things. I dislike the fact that we lie in the dependency scope at the Gradle level just to please Eclipse. I don't like it. I would rather have the correct dependencies in the Gradle project and take the time to fix the IDE integration properly. But the question is, should we do that and spend the time required to do that, or should we just simplify
Can we put some band-aid somewhere? So just move something temporarily so that it works out of the blue for everyone somewhat correctly, even though if everything is not sitting in the exact right place.
If I create a module,
Louis, go fix it. And when you're ready, you merge it back.
How do I fix it?
The answer is you have to fix the Gradle integration in Eclipse and IntelliJ.
Because we really want to use SPI test as a source set inside a module. So having a core SPI test module is not an option.
Wait a sec, what are you saying?
Okay, there's two modules going on here, right? There's the SPI tester, which is the code that...
Yeah, but that's a separate module, and so that's not an issue.
If you write an SPI test for an SPI, yes, it should be a separate source set.
Yes, and the way we do it today is, since Gradle allow you to create extra source set inside a module, we do it that way.
Yeah, it should be an extra source set inside the module that contains the SPI that you're trying to write.
Yeah, that's what it should be. Can we not do it so that for now we have sort of an SPI tests module with all the SPI tests in there and kind of a mess of a dependency, and then it all works? And
how is it broken in IntelliJ and Eclipse at the moment when we do it the correct way in Gradle? Like, is it like
so if you add the SPI tester project dependency to the real scope, which is the SPI test compile scope, then when you import in IntelliJ, it's not seeing that. So it's not digesting that information. And so the core module ends up having only a dependency to the API module, not to the SPI tester one.
Right, so I missed the annotations and the class it extends.
Exactly.
So you basically have a whole bunch of broken compile and error badges.
Again, now I know how to fix it, so it takes like 3 seconds, right?
And once you fixed it, is it fixed for...
Until any build file changes.
Yeah, until Gradle reimports.
Right, then it seems to me like the obvious thing to, if a fix is that, is there an equivalent simple fix in Eclipse? Do we know?
It doesn't fail in Eclipse.
No, you missed the beginning of the conversation, Hung. The problem is the way you change the scope, it's not reflecting what it should be.
The original version that was broken in IntelliJ and Eclipse, is it possible to work around it and make it work in Eclipse with a couple of small changes, or is it not possible to make it compile properly?
I missed the problem. What's the problem again?
So the fix. So here's the situation. So here's the situation. You've got the original configuration doesn't work properly in Eclipse or IntelliJ.
But it does.
No, it doesn't. The original configuration.
Do Gradle Eclipse.
No.
Everything looks fine.
The original configuration.
So I'm going to use the group chat. I hope people can see it if they're listening live.
Who said it doesn't work? Who said it doesn't work to Eclipse?
Who said what?
Who said it doesn't work on Eclipse? Are we sure it doesn't work on Eclipse?
Yeah, because that's why Hank changed it. So Hank, that's what you ended up doing in the dependencies for the core module.
Mm-hmm.
But that's wrong. It's not test compile that has a dependency on SPI tester.
Why not?
Because the real one is SPI test compile needs it.
Oh yeah.
That's the real source set that needs that dependency. But when you do that, at least in IntelliJ, and I believe in Eclipse because that's why you wanted to change it, it doesn't work. And so you need to go add on.
I don't see why the first line would screw up anything else.
No, it doesn't screw anything up.
No. I'm not saying it's screwing anything up. I'm saying it's so by changing it to test compile, you also had to edit.
Well, basically, what's going on, I think I understand, is we're making it an explicit dependency, even though it's a transitive one, right? That's what we're saying.
I know that you try to limit the scope to just SPI tests, but you create yourself a problem. That's why.
But it's not.
That's the true scope. That's the correct scope. The problem is Gradle is more powerful than what IDEs can express. So when you do it the proper way in Gradle, you have to lie in the IDE. So you actually have to add the dependency at a level that the IDE understands, because the IDE does not have that concept.
Well, it doesn't. Well, we don't know that. It at least can't understand Gradle's expression of it.
No, but when you think about the available scope and the source sets, you've got source and test. You don't have in betweens.
Right. Well, that's okay. But can IntelliJ and Eclipse not handle a third source set then? Because that's what it net means. It just says there's a third source set called SPI. That's fine. So,
No. Yeah.
So then it sounds to me like the integration can't be fixed because it's something that can't be expressed. So.
Okay, so what you could do is, we can't fix the auto import in IDEA.
Mm-hmm.
But what we could do is have the IDEA plugin, and then you would use the IDEA plugin, and in the IDEA plugin we had a special section in the module that will create and will add the compile time dependency on SPI tester. And when you do that, you realize that you don't need to explicitly define the dependency in Impl, because it's
right.
transitive.
Right. So can we do that for Eclipse too?
Like I said, I failed for IntelliJ, so I would need to look into the Eclipse bit. The question is it worth working that? Or should we just say we have another module that has a single source set, and that module is a core SPI test? And then
you'll have to have a second module. You'll have to have an extra module for every module that defines an SPI.
Yes. So it means modules.
Well, that might actually be just core potentially. Because core, in the original intention, right, Alex, was that core would define all of the SPIs.
Yeah,
Most
yeah.
of them. So maybe it's not such a
well,
bad.
yes and no. Actually, I thought of that yeah.
It's nice that they're coupled together.
The 107 thing,
Mm-hmm.
and I saw that a cache writer throws a cache writer exception. I was like, maybe it would be nice to write SPI testers for those kind of SPIs, right? That provide a service to the thing. But then I backed off of that. Now maybe there might be others, and so think of a cache load or whatnot. But I think it's stupid, and I'm not saying it's stupid entirely, but those could be controlled like differently.
And so I guess my question then ends up being: do we think we need to be using the power of Gradle in that context? Is it because it's for example?
Let's make it so then. Let's say screw it. Let's go for a separate module because we think it's only one for now. Everybody's happy. The pedants about dependency things are happy. The developers can actually do work in their preferred IDEs, and we all move on happily. And if it comes up as a problem again because we need more, then we can.
We may as well file a bug with the IntelliJ people.
Yeah. And because, for example, when you do the same for integration test, it's not an issue because you don't have dependencies then on that added source set, and that works fine in both Eclipse. So inside the module, when you have extra source set, it's not an issue because the source sets work. But the problem is when you try to depend on them from another. module.
Yep.
That's where the issue.
So also what would work is if we would do what we're doing without having the SPI tester stuff be within Ehcache. Is this correct?
No, the SPI tester is already its own module, so that one is not an issue.
No, I understand. But if we pull this one out as a top level thing somewhere, would that also fix the problem?
No, the problem remains the definition of the SPI test source set inside the core module.
Yeah, but there is no SPI tester source set.
Yeah, there is. That's where Aurélien is working on.
Oh, that's what you call the SPI tester source set. To me, the SPI tester source set
that's
was the source of the
SPI test source set.
Okay, cool.
Different than the SPI tester module.
Then my proposal is to do that.
Okay.
20 minutes on talking build system is already way too much.
I said I wanted to do that last if there was time. You wanted to start.
That's not what you said.
Yeah, that's what I said in my mail.
You said I'm a manager, you better do what I want. All right, so point number 2. Did we decide something there on this? Right, we did, right? Somebody knows.
Yeah, we did. I'm going to create an issue in GitHub, not just now.
All right, so Chris, this one's yours. Vetoing everything.
So, I'm going to talk about pinning as well, just for some historical underpinnings. Boom, boom.
Boom, boom.
Yeah, none of you people probably ever saw Basil Brush, so that makes no sense. This is taking a wild left turn. So, in Ehcache, at various points in time, there's been this concept called pinning, which is the idea that you can pin an element in the cache and not allow it to be evicted. It's originally introduced Greg Luck's insistence in order to prevent soft locks in Hibernate from being evicted, because Hibernate handles it but complains and logs stuff and says, oh, a soft lock got evicted. This is a bad thing. It's not actually a bad thing. It's just, well, it's not a great thing. It's not terrible. It's certainly recoverable. Anyway, we think that such a concept makes sense in 3.0. And so what we have introduced in 3.0 is this concept called an eviction veto, which is a predicate function that you pass in to the cache when you configure it. That cache entries are passed to the predicate function. If the predicate function is called an eviction veto predicate, if it returns true, that thing is not evicted. Great. So you can, if you're running some kind of, I don't know, if you've got something like a soft lock or some kind of transitory value that there are going to be, in principle, some number that is scales relative to, I don't know, say, for example, with soft locks, it would scale relative to the number of live transactions in the system. Basically, you have some small population that's fast moving and is not going to overwhelm the cache, and everything's fine, and you make sure the eviction algorithm doesn't ever accidentally evict one and cause you problems. For example, if you evict a soft lock, it means that the thing is no longer locked. You probably have to have some kind of backout, which is probably going to optimistically or pessimistically invalidate the cache and so on. So it's all fine and great in that scenario where the number of things that you veto for eviction is small. But obviously, like all features, it can be misused. And the question that I want to bring up is, what is the correct thing to do if somebody vetoes the eviction of so much stuff that it is impossible to keep, or that it is impossible for the eviction algorithm to keep the cache within its capacity constraint or constraints?
Okay.
So basically, this is equivalent to I've declared my predicate function returns true all the time. Nothing shall ever be evicted, but you say keep the cache below 1,000 things. What happens when I go to put the 1,001th thing in?
My take is there should be no guarantees whatsoever.
That sounds a bit harsh.
No guarantees of what?
That the stuff that you vetoed will indeed never be evicted.
Okay.
The cache will do its best to not evict.
So your reaction is so your attitude is that the capacity constraint is more important than the eviction veto. I.e., so the way that I see this is, so in addition to the veto thing, there's this eviction prioritizer, which is a comparator that is used to rank, which is used by the eviction algorithms to rank the candidates that they select in order of what should be evicted first. And the way that I picture the current world basically is we run the veto first and say none of those things should be evicted, and then the things that are left we rank them with the prioritizer, and then we evict the thing that's most eligible to be evicted. The question then becomes basically what happens when everything's vetoed, but the answer is what Alex is suggesting, which I think I agree with, and he knows. I think he knows that I agree with that. Is that at that point when you have no choices, when there is nothing that isn't vetoed, you go to the point where you say, fine, I have to evict something vetoed. Tough. Run the prioritizer on that and evict the thing that's most eligible for eviction out of the things that are vetoed. But the key thing here is that you wouldn't ever evict and I'm not sure we should guarantee this, but it's the way that I think most sensible implementations would behave, is effectively vetoing something is like sticking it something at not just at the bottom of that comparator order, but way below the comparator order, that basically a well-behaved store is not going to evict anything that's been vetoed until there is nothing that hasn't been vetoed. So as long as there is one thing left that can be evicted that was not vetoed for eviction, the language here is horrible, I know, then evict that. And when all you have left are things that are pinned or have been vetoed for eviction, you just give up and say, fine, I'm going to have to start evicting these things. Because the capacity constraint is the most important thing.
Yeah, I think so too.
I think that's a terrible idea. You know what that reminds me of?
Mm-hmm.
Soft references.
Yeah, well...
So what's terrible about it?
Right, because what's the other option?
It's
Bring
not
the entire system down? That's better?
The other option is you obey the veto and you blow the machine, potentially.
Okay, maybe in my head I made this analogy, but maybe it's a wrong one.
Right.
I compare your idea of veto and unvetoed and whatever to Java references. So you have hard references, you can never evict, you have too much stuff, you throw out of memory error.
Yes. Why do soft references suck?
Because when the virtual machine runs out of memory, it will start evicting the soft references that usually are used to build caches. So it has to do a lot more work and consume even more memory to rebuild those caches that are going to be evicted again because you're out of memory. You're short on memory.
Right, but this is the inverse. The things that are vetoed from eviction are not the soft references. They're the opposite. The cache, the ordinary things in the cache are the things that are soft references. When we come under heap pressure, we evict the normal things. And one of the things that people complain about most about, I mean, so I've been sat in, I was sitting in a hospital boff like 8 years ago, where the runtime engineers openly admitted soft references. The canonical example, somebody asked the question, I think, like, what are soft references useful for? And they said, oh, the canonical example is building a memory-sensitive cache that you can cache things, and things get kicked out when the thing comes under GC pressure. And as people pointed out, but it's useless for that. It doesn't work. And the reason it doesn't work is because you can't distinguish what pressure is important and what pressure isn't, because the whole heap is not a cache. But in this case, the whole heap is a cache, because the heap is just the cache, and the cache is a cache, and there.
Right, the cache is a cache.
I mean, the point is,
whether it's heap, whether it's this, wherever it's being evicted from, the thing you maintain is a cache.
The main thing here is,
this is key. This whole thing of it's a cache, right? So we should behave like a cache, and to me, part of do no harm is part of like one of the key things of this.
I think the thing to remember here is that when I started out, I said that the canonical use case we expect for these eviction vetoes is live transaction data. This entry is in use by a live transaction. It is orders of magnitude more important than anything else, than the other things in the cache. such that I would like to keep this thing till the very last breath of the cache. And so, in that sense, we don't anticipate that we hit this scenario very often. It is hoped that you'd never have that you only ever vetoing the eviction of a few percent, if that, of the contents of the cache.
Okay, I understand now.
So you never hit it normally. So you don't actually have to. I don't care about how it performs at that limit, as long as it doesn't bring the machine down.
Okay, let me present it another way. That feature wouldn't give you no strict guarantee at all. Okay, but if you have pluggable evictions, couldn't you do exactly the same with your own eviction policy?
Right. So the problem with the policy is that if you had a policy, right, that selects.
Well, you have a policy, but that's the whole thing.
Well, okay.
The policy is the sum of these two things that Chris talked
about. The veto and the prioritizer.
Right.
But if you that's what you get, right? The prioritizer just ranks, but the problem is most of the stores, the way they're going to run eviction is to pick a random sample from the store, run it through the vetoer, and then run whatever's left through the prioritizer, and then pick a thing that's highest priority for eviction. The key thing here is that vetoing is more powerful than the prioritizer, because what we're saying is suppose, for example, you didn't use vetoing, you just use the prioritizer, and you just put the things that are eligible for. You put the vetoed things at the very lowest priority, don't make them very unlikely to get evicted. If you select, say, a random sample of 30 things, you might happen to select 30 vetoed things by coincidence. And what we're saying is these things are more important than anything else in the cache. Therefore, if your random sample selects 30 vetoed things, keep looking. The way I've implemented it for now for the heap cache is to actually the veto predicate gets injected all the way down into the actual selection algorithm, and so actually what you get is it will try and find you a sample of n non-vetoed things, and if that fails, it'll return an empty sample. At the moment, I actually honor the veto above the thing, but the idea would be basically what the eviction would look like would be: give me a random sample, taking into account my predicate, return me n of those. Run it through the comparator, kick out the thing that's most likely to be evicted. If that thing returns empty, that means nothing in this store isn't vetoed. So my fallback will be, fine, forget the predicate, give me a random sample. I'm just going to kick out one of the vetoed things, because I need to save space now. Now, there's two things we can do. One is we can, if we want, spec that behavior. We can spec that in a store SPI. Nothing gets evicted. Nothing vetoed can be evicted until everything that's not vetoed is evicted.
That's what I'm arguing about. What I would do is,
I think that's
for
too
as
strong.
much as the store can, it will never evict vetoed things. But this is not pinning.
Yes.
But this is the pinning bit.
But the question is, how strong do you want to word it? Do you want to? So one extreme is something vetoed never gets evicted. Capacity be damned. Neither Alex nor I like that, but Ludovic seems like he might. The next step down is things that have been vetoed only get evicted when there is nothing else left.
You can't. The problem is you can't define that without locking the entire thing down at point T.
No,
so you can't say that.
So again, I think that the answer is that you should the contract should be worded as things that are vetoed for eviction are considered the most important things in the cache, and then it's a strong hint to an implementer, but it doesn't require anything.
Yeah. First, I have a problem then with the name veto, because it's not exactly a veto.
Yeah, we could rename it.
So that's my first problem. And then, yeah, okay. If you sample 30 elements and you, by accident, you take 30 elements that are all vetoing the eviction, okay, then you resample. and then by accident you may take another 30 elements that are all.
No, but Chris said that, but I don't think that's the way he implemented it.
That's the way. Okay,
that's
so
the
yeah,
way that I would implement
what I was discussing just now.
You just keep on probing until you got either got through the entire set of data from your perspective, prior to you starting, or you filled your set.
Yeah, so what I was describing just now was what the contract is. The way it's implemented right now in the cache tier is you take a you call the method on concurrent hash map VA. I added a get random sample method. Takes returns a set of entries or something. I can't remember, some kind of collection of entries. It takes an n, a random instance to seed from to sample, and a predicate function. And then what it does is it creates a traverser, which is a fancy iterator, internal thing. We've seen it, and then just seeds the traverser, starts the traverser at a randomly selected point in the middle of the map, and then just runs through it, trying to find n things that don't fulfill the veto predicate. And if it gets all the way back around to the start and doesn't find n, it will return what it found. And if that happens to be empty, then it's up to the store to figure out what to do next. And I'm suggesting the thing to do at that point is to declare, even though you can't prove it because it might have been mutated in the meantime, but declare, I couldn't find anything that was not vetoed. So now I'm going to rerun the whole eviction procedure without the veto.
Right, and there are many things you could do at this stage. You could have a store that puts back pressure. You could have a store that that basically is willing for a certain amount of time to go above threshold and then starts. That's the reason I don't want to spec the thing in. Whatever you veto will never ever possibly be evicted. I don't want that to be true. I want something like whatever you veto will only be evicted as a last resort.
Yeah.
Yeah, I'm just worried that this is a sure feature for users to shoot themselves in the foot.
Right.
Well,
So
it's a cache.
right. I think
it's not a store. Deal with it.
Here's the thing. I think you're right. I think if we right now the way it works, given that it honors vetoing above capacity, veto is a good word. But if we change it to, but say, the capacity rules all, and we will never violate capacity, that's the most important thing, then we will have to rename it from veto to something else. And you're right, then you have to make sure you pick a name that has the right connotations and makes people aware. This doesn't guarantee you anything. The cache is going to try and keep everything around, but it can't guarantee it. It won't guarantee it. You must assume that every now and again it'll be evicted.
I'm not arguing we should do that, by the way, but we could have some kind of a pressure like emergency valve that becomes pluggable. And you're there. Whatever that means.
I would just to be honest, I would just evict them and
me too. Honestly, I would do that. It's a cache. You should.
I mean, the whole point is it's a cache. I think if you're using veto, what it's basically saying is, look, you can. It is perfectly acceptable for you to. Well, it's not guaranteed, so you need a backout path. You need to account for the fact that these may be evicted, but it is okay for the backout path to be expensive because it shouldn't happen in a well-configured system. It should happen very rarely, if ever.
Yeah, so big warning saying, okay, if you have
too
many elements, you can completely grind to a halt.
This was a discussion I had with Greg that when he argued for pinning for Hibernate softlocks, I actually said no, we shouldn't do this. Hibernate, first of all, Hibernate has a mechanism for handling when it happens. The logging is just informative. It's not indicating any kind of. And secondly, in a well-configured system, you don't see the warning because you only see the warning if you've got so many live transactions running through the system that you're basically flooding the thing with softlocks, and the softlocks make up a significant chunk of the cache size. In which case, you probably want a bigger cache.
I guess, again, the issue we had with the 2x line is that the eviction policy would never
evict them.
No, would never care about them, really, right? So prior to pinning. They would just be about, like...
Yeah, but even then, selecting... the sample selection is like 30 things. Even then, you need to have a significant fraction pinned in order to get nothing but pinned things and a selection of 30 from the cache.
Well, many people have a single cache to store everything, if they don't have much values but actually do have read traffic. But it's just, again, it's people using the wrong strategy for the wrong thing. But anyways, yep.
So yeah,
Still not sold.
I'm sure he's worrying it's going to make a nightmare for implementing the transactional caches. But do they use pinning still? I think they don't. I think you again have backout strategies to handle it.
I think at this moment there is no backout strategy. So
cool. Oh well.
Kiss your integrity goodbye.
Sweet.
All right.
And that's not what worries me. It's not the transactional.
I will create an issue for doing this, which will be tweaking the contract, tweaking the implementation that's already there, and figuring out what the correct wording is, or the naming is, to imply the right things. Sorry, Alex, that took longer than I expected it to.
That's fine. All right.
So
that was fun.
Why can't he just agree with me? It'd be so much simpler.
So cache loaders and cache writers. So not sure if everybody saw like the some background here in this previous meeting. So basically what we're thinking about doing here is, I would say, getting rid of cache writers. And possibly cache loaders, and merge them into a single thing. This all has to do with the cache, the resilience that we wanted to implement in the cache itself. And yeah, so what more can I say? So I guess simplest. So to begin with, so if the one and single reason you have cache loaders and cache writers is to implement the cache through pattern properly, so that you don't need to maintain your cache on the side because it's much harder, requires you to have ways to do that, which by the way will not be available in well, at least not provided by the cache. There will be no locking mechanisms, right? So how do you actually implement this properly? Is hard, and if it's the cache through pattern that you want to implement, why would you have a cache without a loader or without a writer, right? I'm not really sure why it really makes sense. Certainly without the writer. I can see there are other use cases for the cache loader where we use the API, which is bootstrapping caches and things like these, right? Arguably a read-only cache where you know that you'll never write the data. Why would it need a writer, right? Say a list of countries and whatnot. Though it's probably very easy to provide a loader for that and basically have the method, the writer methods, even throw if needs be, right? If you're, it's like in Hibernate, right? If you, I'm not sure what throws, but if you try to mutate a read-only thing, it just tells you can't do that. I think it does. Anyways, so that's what we're talking about. And stuff becomes really funny when you think about the resilience stuff. So I guess this is now when I need to share my screen a bit to show what I've done. That's useful. I think it bit me last time already. Crap. All right, so here we are. Let me make this smaller. Should become. Viewable.
I just noticed I didn't have Q&A up. Clifford asked a question about eviction strategies.
Should it?
Well, I'm trying to understand what he means. I think when you say strict and lax, Clifford, you're talking about potentially about the difference between. Well, so historically there was a concept called strict LRU in Ehcache, which actually maintained a linked hash map, so a linked list through the values, so that it would actually evict things strictly in LRU order. The fact is that it causes hideous contention issues, and most people don't need it or don't even notice when they don't have it, even when they think they do need it. And so for a long time, the vast majority of, well, default has been, and the vast majority has been to use statistical sampling. At one point, it was a slightly fancier skewed sampling, which turns out to be very good at selecting, well, assuming there's temporal correlation between things that need evicting in each cycle. It's very good. But the kind of the behavior I was talking about, where you run the predicate and then the sample is selected based on the predicate and it runs through the whole thing and finds nothing, is effectively strict, because it's saying I'm not gonna select. It's basically you by doing it that way, you say I won't ever select anything that's vetoed or whatever we call this new thing until I have to. So effectively is strict. From a strict LRU point of view, those things are at the very end, modulo the fact that it might have been live mutated while you're traversing it. But it's as strict as I'm prepared to go without bolting the whole thing down and causing performance issues. Did that answer your question? I'm now waiting for the question to disappear. Of course, Clifford might not be listening anymore. I'm going to let Alex go on, and I'll see, and maybe Clifford will mark it answered, or if not, I'll talk to him about it afterwards.
I'm muted for an hour. All right, so here we go. So that's a get. That right. So there are a couple of decisions I made. So a cache loader doesn't throw cache loader exception, but a cache that failed to do whatever you ask them to do because of a loader will actually throw a cache loader exception, right? So this is the way that a get works. I think I tried to make it as resilient as one can get. And if you see more ways, be my guest, correct me. So first off, what I do is I create a function that's going to be the one that tries to load, right? So if there is no loader, basically consider this returning null, right? So we have this function. So this function is a memoizing function, meaning that it will only ever execute once, and then after that, it will return you the whatever it calculated then. Okay, so it all starts here. Now, when on the store, what you do in order to do a get is you invoke the compute if absent, right? So basically, if the value is there, you'll get the value back. So that's line 94 and 97. If the value isn't there, it's being computed. Okay, so being computed means possibly loaded, which could throw an exception. In turn, will throw a cache loader exception, and then other things happen. All right, so that's it. Okay, I try not to pay attention to the background stuff being discussed.
Sorry.
Okay, so do all that. That's fine. Now, if the cache itself, i.e., if the store throws, right, you get a cache access exception. You don't know whether you loaded or not. You have no idea. So if we didn't load, it means we never got to executing the function. Probably means, like, if you think in a distributed system, if your data set is sharded, you didn't even get to the stripe to go see if the thing's there, right? That's basically what it means. You couldn't resolve the if absent bit. So if the absent bit failed, what we do is we try to remove the thing from the store, right? Say if it's on disk, for instance, and it's a old serialized representation or a non-compatible serialized representation, and when you try to fold it back, it just screws up. I'm not sure, by the way, that we want remove here. I'll come back to that later. So if this works fine, we actually let the resilience strategy that we recovered from an issue here. The reason we say we recovered is because, well, actually, arguably, we should only do this if there is a loader? Maybe, I don't know. Again, more questions on that later. But because basically what we'll do is we'll just re-ask mapping function, which is this memorizing function, to do its work afterwards, right? So basically what happens if we had a bad value in the cache, it just got cleaned up. It didn't repopulate the cache, but the user got the answer he was expecting. Okay? If we can't remove, though, and if again you think in distributed world, that's a problem because you're possibly inconsistent now, right? You got possibly an old value in the cache that we couldn't get rid of, and you loaded another thing from the underlying system of record. Okay, does that make sense? Because that's the easy bit. So here is the same kind of logic for a put. It's not much more complicated. So same thing again, a memorizer. We know how to write the value to the underlying store. So what we do is we compute whatever, it's a put, right? Whether it's there or not, go find this key and execute this function atomically. The function, what it'll do is it'll try to write the thing and then return the value back. And we make sure that so that it gets written to the underlying system of record and atomically put in the cache by this return, which puts it in here. So nothing really fancy here. Again, if something goes wrong, we don't know if the write happened or not. So if it didn't, we just reinvoke the function. It's a memorizing function again. So worst case, it just passes a pointer around. If needs be, it calls the writer. And we try to get rid of whatever was in the cache, right? Because if it happened prior, need to make sure we clean things up. And again, we tell that we recovered. If the remove, again, didn't succeed, that's a problem because it could be that the old value, if there is a value, it could be the old value in the store, and we actually wrote a new value down to the system. What then this does is up for anybody to decide. This could actually throw an exception and have everything fail, right? So there is one last case. If doing the write actually failed, what we need to make sure is that we delete the entry from the store. Same thing again, just do the delete. If it succeeded, we invoke that. It's just a poor man's callback. I'm not really sure if we need to keep this. And then if we couldn't remove it, well, we're possibly inconsistent, so same thing, we tell the strategy about it. Okay, yeah, somebody wanted to say something there.
I don't know, I just had a horrible thought.
All right.
You can't call the writer from here safely because you've broken any atomicity guarantees. Imagine if I've got two calls, two different threads.
That's why I removed.
Right, but if you ever call the memoized, isn't there's one point where you call the memoized function from outside the store?
Yeah, here.
Right, that's not safe.
Why?
If that's
the case where everything's screwed, right?
Right, so, but you've dropped out the lock scope or whatever was enforcing atomicity between the cache write and the write to the writer, which means suppose you have two writes, right? The first one fails for some transient reason, it's fixed. The second one comes through, manages to do its write, but then you go and call remapping function to apply after that second write. That write is no longer correctly ordered.
With regards to what?
The earlier one, which may have done a read to validate it. Yes, you can.
No, I don't think you can. No, I don't think
it's observable. The point is, once you get outside of the store.compute, an infinite amount of time can elapse between that and calling remapping function to apply, during which the system of record can advance through who knows how many states. And your write may have no correlation to what should be happening.
Right, but that becomes the writer's problem, right? So that's in this discussion we had, you can deal with all those things. Oh, yeah, I just realized, no, but this can throw a cache exception and you again come here. Right, just as you could implement an optimistic locking strategy in there to make sure that that's up to you, do what you want. Yeah, obviously you can't expect. But the problem is it could be that because you think about atomicity, right? Because you're actually thinking of the cache or the store in this case. Being the thing that actually is the synchronizer, right?
Well, who is the synchronizer?
Well, potentially maybe the cache is a synchronizer, but potentially it's gone. If it's a stripe in a cluster, and you can't talk to it, there is nobody to talk to.
Right, but if it's only. Isn't it only so? You're right. It is safe to call that if it's gone, but only if it's truly gone forever. If it's back and it's happily synchronizing for other threads, and your failure actually happened a while ago, but you don't realize because the scheduler screwed you over, then you can't just.
Wait a sec. We're talking about distributed system. If it's partitioned, I
have to be distributed system.
No, I understand that. The problem is define gone is the thing I'm saying. You cannot define.
Well, it's not a transient failure. That you're assuming that if it failed for you, it failed for everyone else.
No, I'm not assuming that.
Well, if it didn't fail for everyone else, then again, the argument stands. You can only safely call the remapping function if whatever enforces the atomicity is scoped outside of this. So, i.e., the point where you call remapping function .apply is within the bounds that define the atomicity, right?
No. Again, you need to have your writer have some strategy to deal with
places.
That.
Why? No, but it isn't the point of the write-through cache or the cache-through that the cache is doing its own locking to enforce that the cache itself stays in sync.
Yeah.
I'm saying that this. Well, I suppose the remove guarantees that.
Yeah, but that's why the remove is there, which cannot be guaranteed either. Okay. So this is why eventually you may get to this, which may say, "Oh my God, we're screwed."
Yes, we're possibly inconsistent.
But yeah.
We just have to be careful about like. Yeah. Okay. I was just I'm being paranoid. You're right. I was just something I hadn't thought about, and then my brain suddenly said, I think there's a problem. But it's not.
No, well, there is, it's not all solved, but basically at some point you just delegate to
it's the point
somebody else to deal with it. We can't.
Well, it's the whole thing that if the thing you did, I guess it's teaching someone how to use a cache through properly. If the operation, well, actually, is it? I don't know. If, for example, the operation your cache writer is going. No, it's fine, I guess. Yeah, you just have to be careful about what the cache writer does on each write and how you interact with the cache in a way that you make sure that you don't just blindly do a write that really should have had some kind of updatey style constraint applied to it.
I don't know what you're talking about.
So yeah, I've said nothing. Sorry for making everybody panic.
So anyways,
probably not. Sorry for sounding stupid.
That's the easy bit, as I was saying. Then
the hard bit is figuring out what to do when you're possibly inconsistent.
Yeah, that's certainly hard. The good news is that what we've decided is we delegate this to the user. So one option that I can talk about is this one here, right? So this is why I said remove might not be the proper thing. So one better method that I thought about was obliterate. And that possibly you give the strategy like not only the key but also the thing that can obliterate to the strategy, right? Because one thing you could do is, for instance, enqueue this thing for later, like for being obliterated sometime later. And why I mean obliterated is because what we're saying is that this will possibly not invoke any listener. So the most simplest thing to think about is it's in serialized form. Never ever try to deserialize it. Does that make sense? So
yeah, the other thing there's some clever stuff you could do as well. Potentially, you could blow away every key that has a hash code that matches that one. just in case for some reason you couldn't deserialize the key to do the equals comparison.
Right. Well, that could be obliterate again. That does that, right?
Yeah. Obliterate guarantees it removes this key. Might do who knows what else to the cache in the process, but is guaranteed to at least remove this key.
So, so something around those lines.
Cool.
Okay. So then the funnier bit is when you get to those methods. Actually, put if absent wasn't that hard. I must have done it wrong.
Probably.
Why do I have to try? I really want to catch it.
I think you need a third one.
Yeah, you never know what might happen there. Probably know why I did that, by the way. I have patterns where I had the try in the if, and others where I had it outside. It really bugged me, so I like it.
These cache loader things going to stay? The cache loader conditionals.
The null?
Yeah.
No, let's discuss this later.
Okay.
We can, I would like not, but it comes around with a bunch of questions. So, anyways, so same thing. That's a put if absent. So basically, what it does, if the thing is not there, and let's say there is a loader, right? Because it makes it much easier. If there is a loader, we'll try to load the darn thing. If that fails, the entire thing is supposed to fail. If we loaded something, well, we just install this in the cache and we don't write anything out. If we didn't load anything, well, we write this to the underlying system of record and we try to populate the cache with the thing we just wrote. So it just became hot, even though it should return null. So
this method was put if absent, right?
Right. Okay. So this does a compute if absent, same thing. So if the thing's not in the cache, try to, so if it's, if it was in there, you just invoke the darn thing. Actually, I realized this is wrong. This shouldn't be value here. Probably. Anyways, I'll have to think about that. So, same thing. It probably is a memorizer again. Yeah, make sure that it's not invoked twice. So if stuff goes wrong, do whatever you need to do. So this one is actually not too complex. Again, maybe something's wrong in there, but it's not the end of the world. Stuff becomes more funny in these things. A remove or a replace. And the reason why it becomes funnier is the reason that, so say you want to do a remove, right? You pass in the value here, and it's not in the cache. What should the writer do? Should we necessarily load the thing in memory, see if equals matches, and then try to do the remove?
Well, right now you have to.
What do you mean right now I have to? No, I don't.
Because you don't have a 2-arg remove on the writer.
Well, yeah, actually I do, because I added it.
Okay, I didn't know that.
So, where is it? It's here. So it's a delete. That takes that and also tells me whether it succeeded or not. Because one thing that I need to be able to tell, so with this approach, what I can do is I can actually write something in here that will try to do the remove. If it's not in the cache, it actually is going to go down to the system, to the writer, ask it to do the remove and see if it succeeded, read the answer back from the writer, and then return, right? So do we want to, is this where we want to go? Is anything around everything I said crazy? Once you've looked at all this, what do you think about the idea of merging the cache loader and the cache writer into one? And then the question that Chris asked, in order to get, so if you merge them in one, it's pretty cool, right? Because you never have to do this. But basically, you end up in a situation where you can have a single cache through cache implementation that knows it will have a reference to knows how to load and how to write and do everything automatically. And then also what you can do, because obviously this is all Java not 8, meaning there is a whole bunch of allocation going on, we can elite all this in the non-cache through case.
Yep. I did backtracking. You added a 2R delete or remove, whatever you want to call it.
Yeah.
For some reason, you didn't add a put if absent. So when you look at the put if absent, right?
Yeah,
you you're relying on the cache's exclusion.
To load. Yeah, but that's fine because the put if absent also needs to return the value. So loading it is not an issue. You need to load it in case it's there. So you don't need that on the writer.
Right. But the writer doesn't know that what you're doing is a read followed by a put if you see null. So what I'm saying is what you could do is give the person the opportunity of mapping straight down to a native put if absent against their system of record, which might be more performant than you doing the logic.
Right. So what I would do is then this, like write.
Yeah, this is the argument.
Like insert, for instance, right?
Yeah, so this is the thing I was talking about earlier, where basically, to me, I think there's a good argument that says that there should be an operation, and when I say operation, I don't necessarily mean method, but way of representing doing something for on the writer for every equivalent there is on the cache.
Right. Yeah. I don't know.
I mean, you don't have to have it. Obviously, like I said, you can do it the way you did it. But you can equivalently, like, at some point, you've got, like, to me, there's a continuum. At one end is really minimal stuff, like less than what you've got there. And at the other end is a method for the one-to-one method correspondence between the writer and the cache.
Yeah, maybe I should try it because I realized, right, it would be a Boolean, like uppercase B, because there are some cases where you don't know. Right? A straight put. Is it an update or an insert?
No, you don't know. It's just
if the cache doesn't know the value, doesn't mean that.
Well, it's like that. What you're doing there is what was it one? I think one of the CHM versions, don't know which one, does this, where it says Boolean only if absent or something like that.
Right.
But then at that point, what are you buying? Just have two methods. And of course, in 1.8 you'd have it so the default did something sensible, but no.
Okay, so nobody calls me entirely mad quite yet, or?
I think this makes sense. I think you should combine writer and loader. I do. I don't care what it's called. The name I keep calling it is really crap, so let's not use that one.
And then what I have there is the cache. What? That's the cache through then implementation that I'm writing.
The cache through implementation. Cache through.
Yeah, that uses cache through. Okay, so merge and make that. So that's kind of good. Okay, so what else?
I mean, if we're really confident that these things are only ever in front of system of records, call it system of record.
Yeah.
Or system of record accessor or sort accessor. Or
yeah, I was thinking about data source, something like that.
Data source or something like that. Yeah, something Springish.
Right.
Because that's really, if that's what we're claiming it always is.
Right. Okay, so looks like this is not entirely crazy. I think I'm gonna finish this like the replace or whichever one I was on, and the remove.
Mm-hmm.
Right, the remove. I'm gonna do the remove, and after that, I think I'm gonna split this whole thing so that other people can work on it.
Yep.
And then call me crazy. What else are we saying here? Yeah. Okay.
Clifford asked a follow-up question to the earlier question. This is mostly, I was wondering if there was a reason for permitting an or the like. To which, and that's what Alex was talking about earlier, which is sorry, I'm backtracking, but anyway, I should answer the question. Is what Alex was referring to earlier, which is that at least Alex and I think most of the people are fairly confident that if this is truly a cache, and that is one of the things we're really pushing for, is that Ehcache 3 is purely for caching. It's not for anything else. If it is purely a cache, the answer is no. There is no justification for a cache to cause an unless it's been explicitly misconfigured.
Right.
So fine. Yeah. If you configure the memory limits wrong, yeah, it'll out of memory. But if you're within, if you've given us constraints and we violate,
true, right? Even that in the 2x line, Well, except if you do like numbers, yeah. So
I think. Put it this way. I think, assuming it's configured to stay within the limits of its environment, it should never out of memory.
No, and that's the whole point. I mean, if you look at all the methods, like all the code we just went through, it's all about that, right? Never failing. Just never be the point. Try to never be the thing that's going to let your system down.
You're a cache. You're a supplementary and ancillary part of the system. As much as people can say, oh, caching and in-memory is no, if it's a cache, you can take it away and the system behaves the same way. It's slower, but it still behaves. So the point being, the cache shouldn't cause the system to fail.
Right.
So it shouldn't be able to make it
Theoretically, this sounds good. Practically, we all know that's a lie. But anyways.
I know, but where we can honor that.
All right, let's take another 5 minutes and try to nail the last topic down. What do we do with time mucking?
We try and do it, but it's very difficult. In some places, you just can't.
No, that's not true. I think you always can. You just need to plan it early on from the beginning. This is why I'm raising the problem now. And the one proposal I'm making is exactly the one we have in SluClock. I find the thing so that you can feed any system exactly with a time source.
The time source.
Right, but then you need to abstract all object.wait, all. So you're going to have to abstract a whole bunch. Basically, you're going to have to abstract all the object waiting. You can't ever take an object and call wait. That's the thing that's annoying. Because there's some points where the language inherently interacts with the wall clock. And you have to abstract all of that out into your time source.
We're going to use that a lot.
No, but it's annoying to have to do it sometimes.
When? How? Where? One single example.
I didn't say we were going to use it. I'm just saying that there are...
No, that's what I'm thinking too. I think it's not applicable. It's irrelevant. I mean, think about... what we're talking about is expiry, right? That's basically the problem we're dealing with.
I think there are potentially places in, for example, com stuff and things like that, but that's not going to be inside the open source code. Yeah, for the open source product or project, it's not. I think we can get away with it.
No, and again, the scope of what I'm talking about is expiry. So I think it's perfectly feasible.
For expiry, yes. We should probably, but somebody should spec that interface now and start using it, because the longer we go without it.
Well, the good news is that there is a task that exists that's about working on issues that's expiry, and I think I'm going to spec that in there.
Okay.
These tasks include specing a time source SPI to inject all. How would you say time sensitive parts of the system? Nothing should explicitly call to system.families. All right. Out there. Somebody can actually do this because we have the first thread sleep in there and blah 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 because of the value holder. And I think we can do without that.
Yep, and I agree. We need to do it now. It's going to be easier and get rid of that sleep.
Yep. Alex, you know the person that's working on the IntelliJ bug, apparently, according to LinkedIn.
Okay. What bug?
The one that causes Gradle to not work.
It doesn't seem anyone is working on it.
It says he's assigned to it.
Doesn't mean he's working on it.
Well, assignee, Vladislav Soroka.
Okay, I added a comment.
Yeah.
Cool. All right, so...
I added a +1. So if you want to all go to it and +1.
How do I +1 on this?
You need to be logged in.
So is that it for this meeting, or anybody else wanted to raise something?
It's done for me.
Not raising, but on the cache loader and cache writer stuff, maybe probably I should ponder all that has been discussed in this meeting first, but there are some things that popped into my mind, and I wonder if we... Okay, basically what it looks like what we're doing here is some kind of transactional system on the cheap, a simple one. You're trying to keep, well, not transactional system, two-phase commit system.
It's not
keep your cache in line with your system of record.
But it's cache through, it's not cache aside, so it is transactional, but it can be enforced through.
That's what I.
No, it's not transactional.
It's not transactional. It's two-phase commit.
Yeah.
I don't even think it's that, but. So anyway,
no, it's not because it's more like.
Say, I still don't know where you're getting with this.
The next step I'm getting to is in your method that is now called potential incoherence, that you end up to the user. It's up to you to handle it. I think they will be really angry if we just gave them an interface and help yourself.
There's nothing else you can do. What would you do instead? It's the truth.
I think we could help them.
How?
How? If we could, we'd do it. So I'm more than willing to hear what you have to propose.
Well, I think we have to pick one or maybe many of the existing strategies and present them as default implementations that you can take.
Strategy? What strategy? The cache is potentially dead or out of context.
Yes, but one way or another, you will want to reconcile your cache with your system of records.
Well, okay, there's two problems. One is how you reconcile. What do you
decide to throw an exception?
In the meantime,
I didn't get any of what you said.
You guys talk over each other.
There's two problems. One is how do you reconcile the state? Well, the answer to that is easy. The system of record wins. It's a cache. The second problem, but the bigger problem is not that. The bigger problem is, say it's a clustered cache. Or a distributed cache in some way. What do you do with all the other people interacting with the cache in the meantime when the cache didn't get updated but the system of record did? They're seeing stale data.
Right. What we're talking about here is reconciliation algorithms, and we don't know what.
There's no transport to reconcile, even. Yeah,
well,
there's no way of transmitting the data.
Not now, but it might come back. Honestly, what I think the most sensible thing to do is to throw, right? Catch, so throw my 211 exception, right? So you catch that, and then you deal with it, right? And I believe that you can sort of always deal with it without giving a 500 to the user, because that's my main problem. The thing is, what we said we would do is that the strategy that we're talking about, right? When you get to that, most probably it's going to be a throwing one, I guess. Or the other thing we said is that we wouldn't inject one by default if it's clustered, for instance. If you're in a clustered topology, you also need to provide me with the resilience strategy that you want to use. It could well be that we come up with one that just throws some exception, right? We could have some that just lie to you and consider everything being a no-op, right? Like the non-stop stuff. It's we can do things. The problem is we cannot guess what is the right thing to do, so we decided we will not guess and we'll force the user to make a decision. But for heap caches, right, this possibly inconsistent thing, it's not possible to reach it. You'll never reach this point. The cache will sort of always be able to auto-heal. Like in memory, same thing, other than for UMIs. But for
serialization problems.
No. It should be able to auto-heal. That's the value proposition.
Auto-heal, yes. Sorry,
yeah. So you don't get to the possibly inconsistent stage, right? The possibly inconsistent state is when you're in a distributed system and you just don't know. It's and then only somebody that knows the real domain of the app can start doing things. I don't think we can.
I agree with that. It's just that I just wanted to point out, even if we have to implement to provide some default implementation, even if that means the user will have to explicitly configure one of the ones we provide. Even if we only provide one that just throws an exception or log a message, we will have to provide some.
Yeah, I think that's what will happen. How about that for an answer? I don't. Very fundamentally, what I think we should do is nothing. Best case, provide an abstract one where you just implement this one method, and if you want, you can put throw new runtime exception E. Right. So I'm not sure whether you saw, but actually the method signature for that is like key, the root exception, and then a var arg of exceptions, which could come with in sort of the order in which they appeared. So there is always a root exception to why we're in trouble. And then there are all the other ones.
Which are probably exceptions that were triggered when we tried to recover and failed.
Right.
Mm-hmm. And could we think of a way, well, that would make the logic even more complex then. In that error handler, tell the code, okay, now retry. I fixed something, like I waited 5 minutes,
sure.
And now retry.
That's why I said, yeah, but retry what? See? So another thing that I had at some point is, give an int to, I think Chris I'm pretty sure, Chris pushed it to actually pause the method handle of the thing that was trying to be invoked, right? Basically, this retry. And say retry.
Just call it.
And yeah, that might be one way. Honestly, again, since it's a cache, I think that the obliterate thing is just good enough, right? You get the key, so you know the one thing you can't trust anymore, and you get a handle on how to kill it as soon as it's killable again, right? Because the contract being obviously that for as long as it's not killable, it's also not readable, right? It's basically it's unreachable, and when it becomes reachable again,
well,
it's
unreachable by you.
What?
Unreachable by you.
Yeah. You at this thing again. You could have back mechanism to actually tell people. But anyways, at this point, you know that you couldn't. That possibly you did the right, for instance. And then when you tried to install in the cache, it didn't work, but you know there was no value there, right? You can, in this case, in the possibly inconsistent state, you can know this by the exception you'll get. You can actually throw another exception or even deal with it in the strategy to tell, all right, so I'm backing the whole thing out, right? But these are reconciliation things that I cannot make guesses what works for a user. It depends on the system of record underneath, right? Think about it. If it's a database, the transactional database is pretty easy, right? Throw a runtime exception, Spring or whomever is going to call it, and somebody's going to call transaction rollback. Nothing ever happened. We're good. But that's not necessarily the thing that sits underneath.
Yeah, I'm thinking, for instance, LDAP.
I can think of many things that could be sitting underneath. Yeah. So anyways, does that all make sense?
Yeah,
I still believe we're kind of crazy on the thing we took upon. It's I don't know. How I don't know of anything that works this way today. Why not?
Because Hambar, here's a question: how many enterprise caches do you know?
That might be.
What?
Yeah, that might be it. Yeah.
That don't try to do something else too. And so therefore can't be resilient caches, because being a resilient cache naturally means being a crappy anything else. There aren't many.
Oh well. Will be.
I don't know. Memcache? But I don't know about any memcache. I mean, I don't know.
Memcache is always cache aside. I don't think there is any.
Yeah. Nobody tries. Yeah, and Guava, which is aggressively cached through, it's heap only. So.
Yeah, obviously heap only solves many problems. So, anyways, we'll see. I think this is why I think it's kind of cool that everything we do with regards to that actually will work with 107, right? Will make sense in 107, so we can get this out hopefully pretty quickly and gather feedback. All right, on which I guess I'll write this whatever method I was writing, the remove, I think, the 2-hour remove. Once I'm done with that, I'll probably do a pull request of all this and redispatch all the different issues that are currently all assigned to me. Well, I won't redispatch them, but I'll release them. And whomever wants to pick on something can pick on something, and I'll go back to finishing the writer stuff. The writer API.
Cool.
All right, cool.